So this is structure 1, and now let's work on the same for structure 2. Formal charge for nitrogen. Again, nitrogen should have 5 valence electrons, and lone pair electrons or non-bonding electrons, that's 4, minus 1/2 of 4 bonding electrons. So that should give us minus 1 formal charge for this nitrogen. Now for the central atom carbon, that should be 4 because it's in the 4th group. Minus, again, there's no lone pair, just like in structure 1. 1/2. Okay, each line represents 2 electrons, so therefore that's total of 8 bonding electrons. So that gives us a formal charge of 0 for this carbon, and now the formal charge of this oxygen. Valence electrons, 6. Lone pair or non-bonding electrons, 4. Bonding electrons for this oxygen, again, that should be just 1, 2, 3, 4. Each line, has 2 bonding electrons, so that should be 4. So the formal charge, according to this calculation for oxygen, is also 0, though. Now, question 1b asks, based on the formal charges, determine the most favorable resonance structure, whether it's 1 or 2. So, in order to determine which structure is resonance structure is more favorable, we need to look at the formal charges. Okay, the resonance structure that is most favorable is the one in which the formal charges on each atom is minimized. Okay, let's take a look. You see here, -2? That's further away from 0, all right? So, so that's -2, 0, +1. You see, among the 3 atoms in structure 1, 2 of those have formal charges, and for the nitrogen there, so the formal charge is pretty large. So then that's not good. That's not favorable. So smaller formal charges is more favorite. And also they should be so the formal charges should be evenly distributed throughout the molecule, in this case, the ion. Based on this analysis, you see structure 2 is -1, 0, 0. So it's much more minimized than here, the formal charges. So that's why structure 2 is more favorable among those 2 resonance structures.